What is the significance of this picture? Just observe that. Okay, just see that picture. So what is the significance of that picture?
Shadow.
All of you.
Shadow.
Yeah. Yes, any other? So normally in this picture it is orthophoto. If you can see, you can identify that those are all camels, right? How you have identified? Actually, those are not camels. Those are the shadows of the camels. Okay, actual camels are that white, very small. Okay. If shadow is not there, it is difficult to identify the animal. Is it not? So here you can see the whatever the small features are there. These are all camels, right? The shadows. The shadow is giving you the information of the that this is a camel. So in further classes we will be discussing these topics also. Why we are going to choose the shadow, then pattern, shape, size in identifying the object. Because the price, so that is the significance of that is you are identifying the animals based on the shadows. Yes, close this. Then today we will see the basics of remote sensing. I think some of you might have got the exposure, but this is a beginning class. So you just start that satellite data. Satellite path. So what is remote sensing? So in the next 2 weeks, we will be seeing the remote sensing, GIS. Okay, then GPS yesterday evening, one of the professor has taught you. Then the combination of these things, artificial intelligence, everything will be seen. So you can see how the satellite moves. So it has got a path. Is it not? It is going to take the pictures like this. Well-defined path will be there. So yes, now start the presentation. What is remote sensing? Remote control. Daily we are using that. What is remote control? Earlier days, if you have TV or AC, you will go manual and switch it on. Is it not? Now, by having some device from far away place, you are controlling that machine. Similarly, remote areas, far away from the normal areas. So, remote sensing. So, remote means, now you got the idea. You are not touching, you are away from that. Sensing means you are getting some information. So, yes, next. So, remote sensing is the science and art of obtaining information about an object, area, or a phenomena through the analysis of the data acquired by a device that is not in contact with this area, object, or phenomena, which we are going to discuss. Suppose I am getting information of a building, I am getting information that this is a table. So how I am going to get that information? By seeing with the naked eye. Eye is also a sensor. Eye is also a sensor. So the satellite, without being in touch, it is getting information of the land, water, remote sensing. So remote sensing is the science and art of obtaining information about an object. It may be an area or it may be phenomena. So temporal changes of a city over the 30-40 years period. So 1970, 1981, 1990, 2000, 2010, 2020. Like that, if you have taken the satellite image, you can see the city urbanization, how it grows. The phenomena, right? So these are all the two definitions. Remote sensing is the acquisition of physical data from an object without touch or contact, and it is reconnaissance of a distance. That is, those are the two technical definitions. Next slide. So just I will, today we are going to cover the basics. So I will give what is the process of remote sensing. In this, the left side corner, you have seen, what is that? This is sun. Sun is the major source. In hydrology as well as in remote sensing, sun plays a key role. Sun is the source of the energy. It provides the electromagnetic radiation. Okay, energy is in the form of electromagnetic radiation. Then what happens to that energy or radiation? It travels, it enters into the Earth's atmosphere. Then some phenomena will occur. Scattering will occur, absorption, transmission, like that. So many things. Reflection will occur and it will reach the Earth. Whenever it reaches the Earth, Earth contains different, means you have the land, you have water, you have the trees, it may touch the buildings in it. Then what happens is some of the energy will be absorbed, some will be transmitted, some will be reflected. The reflected energy again passes through the atmosphere and the sensors. Now I am telling about the satellite. The sensors are rotating and it is going to get that, grasp that information. Or electromagnetic radiation it is going to get. So starting energy and ended energy. The total energy is constant because some of the energy may be absorbed. But what happens? There will be reduction of the energy, electromagnetic radiation. Okay, that sensor is going to record the information. Then that information will be transmitted to the ground station, Earth station, and from there it will be taken by the user. So it may be depending on the size, depending on the requirement, they will be getting the information and after some corrections they will be using that. So remote sensing, GIS, both are, they will work in tandem. So remote sensing is the information, the data. Okay, in lab session I will show the topo sheets, the satellite images, all those things, but up to know what is the information, how we are getting the satellite images through this process. Okay, next slide. If you have any doubts after that I can explain because within 1 hour I have to cover some portion. So energy source is the sun, then propagation of energy through atmosphere, interaction of energy with Earth surface features. Whatever may be the features. It may be a mountain, it may be a tree, it may be a building, it may be water body also. Then after that, again it will repropagate through the atmosphere and then ground station and then finally data products. Right? So what is the significance? What is the significance of this particular figure? The energy is passing through the atmosphere twice. Energy is passing through the atmosphere twice. So in the further slides, what we will see is energy interaction with Earth surface features, energy interaction with atmosphere will also be seen. In this, we will have some interesting phenomena. Why the sky is blue? Why the sunset during that? Why it is red in color? Why the clouds are white? All these things will be answered in this particular session. Okay, because of this phenomena. Next. So now remote sensing, whether it will occur in the night. The source is now okay. The normal phenomena, normal satellites, their energy should be there. Okay. So here in this slide you can see the two things. What you have observed, the satellite is moving. Then passive, active. What do you mean by these two? What is the difference? In the passive, just go to next slide. Passive remote sensing, active remote sensing. In the passive remote sensing, some external source should be there for illuminating. Then you can get the information. Whereas active means, active remote sensing means it will have its own, yes, illuminating source. So here the very simple thing is camera is there. Night time if you want to take picture, what you have to do? Some external source you have to show. But there are some advanced cameras. It will have its own flash. So that is one source. That is active remote sensing. If somebody providing the illumination, it is passive. So there you can see in the first picture, sun is there. So that's why that particular small plant will be visualized by the boy and also camera and also satellite. If the illuminating is not there, they could not able to get. Okay, here it will have its flash is there. So one source of illuminating source is there, so that you can identify. Next. So this is already I told that energy is there. It is passing as a electromagnetic radiation. So what is this electromagnetic radiation? So here you can see the energy from the sun, it travels like this. The electric wave and magnetic wave, electromagnetic radiation. This is the most important concept. What is that? Every object above absolute zero temperature, it emits the radiation, depending on its temperature and emissivity characteristics. So all objects on the earth whose temperature is above absolute zero, it emits some radiation. The table, building, water body, every object is going to emit the radiation. This radiation, some of the times you will not feel, but radiation will be there. So this radiation depends on the temperature and its characteristics. Each object is unique. Each object is unique. So next slide. So electromagnetic spectrum, electromagnetic radiation, it will be arranged in terms of electromagnetic spectrum. So electromagnetic spectrum may be defined as the orderly arrangement of the radiation according to the wavelength. Electromagnetic spectrum that we have to define such that it is you are ordering the radiation according to the wavelength. Small wavelength, long wavelength. Okay. So the sunlight is in the form of electromagnetic radiation, which is most common. There will be other source of energies also, but sun energy is moving as electromagnetic radiation, which is very familiar to the human beings. So what this electromagnetic radiation contains? Electromagnetic radiation contains all types of waves, cosmic waves, X-ray, then you have visible light, gamma rays, then you have got the radio waves. So during the radio transmission or TV transmission, it has to go a longer length, longer distance it has to cover. So its wavelength should be long. Whereas X-rays, cosmic rays, it will have very less wavelength. Okay. Then next slide. Here you can see the wavelength, how it is being distributed. So on the top, the wavelength is in micrometers. The wavelength is in micrometers. Gamma rays, X-rays, ultraviolet. Then you have the visible region. After that, infrared, microwaves, radio waves. You can see the vast range. 10 to the power of -6 to 10 to the power of 7. So it contains the radiation is split in terms of wavelength we have placed. So what is the visible region in this? What is the visible region? Very, very small, is it not? So the unit is in micrometer. The visible region is very small, that particular small portion. So it is, this is given in nanometer. Can I tell 0.4 to 0.7 micrometer?
Yes.
0.4 to 0.7 micrometer. That is the range. And what are the standard colors? Standard colors are RGB, red, green, blue. Red, green, blue. Okay. So blue, green, red. Red has got more wavelength when compared to green, and blue has got less. And within that we have another category. What is that? Most common, 7 colors, which are violet, indigo, blue, green, yellow, orange, red. Okay. So blue, lesser wavelength, green followed with red. So this will answer one of the questions. Why the signals are red in color? We have only very limited range, visible light. In that, red color has more wavelength. So what is the significance? Why red is danger? No danger, nothing like that. Red can be visualized from far away place when compared to blue or green. That is the answer. Not that red is danger. Is it right? So red can be seen from a longer distance. It has more wavelength. This is the technical answer. Okay. So within the small area, we have blue, green, red. Please remember this because further classes we will be discussing false color composite, where we will be assigning different colors. So, what is the inference of this? We have wide spectrum but very limited area where our human eyes can visualize. Next. Yes. Now, within that small area, we are going to utilize for remote sensing. Then what is the use of other spectrum? No, not at all. In infrared region also or microwave also we can utilize some of the area to extract the information which by naked eye we cannot visualize. By using this remote sensing, in some of the areas we can extract the information. So that's why we will be using some other parts also. So thermal infrared, then we have radar, microwave remote sensing is there. So that we can utilize this different wavelengths also. So next. Yes, now as already I told, the energy as electromagnetic radiation is passing through the atmosphere. When it is passing through the atmosphere, there will be some changes and finally it is going to hit the land. So what are the interactions? When electromagnetic energy is incident on any feature of the Earth's surface, three fundamental interactions will happen. What are those? One will be some of the energy will be reflected, some will be absorbed, some will be transmitted. The three things. How much will be the portion that is reflected, transmitted, and then we have absorbed? That depends on the characteristics of the particular material. Suppose it is falling on the water, then transmission, absorption, and your reflection will be different. Whereas it is falling on the road, it is different. Okay. So spectral variation in magnitude of reflected energy is utilized to discriminate between various objects. So how it is being reflected, that we are going to utilize for discriminating various objects. What is the purpose of remote sensing? You want to get the information, no. So we are going to utilize this particular phenomena. Yes. Next. Yes, here you can see the sun is the source. It is passing through the atmosphere. It is hitting the forest, water, grass, bare soil, paved road, and then built-up area, and then apartment. And all the things, the three interactions will happen, and finally energy is being reflected to satellite. Satellite is going to get the information from the forest, water, grass, soil, paved, built-up area, and apartments. But this received, whatever the energy is there, that will be varying in quantity. So, depending on the quantity, we are going to identify what is that object. What is that object? Next. Yes, here the other thing is spectral signature. All are very much interconnected topics. What is this spectral signature? So, everyone has got our signatures. What is the significance of signature? You can write the name also. Signature means that is your unique thing. Okay, so that you can identify this. This is my signature. Nobody else can do that. Similarly, here objects are there. Each object has got its own unique signature, its reflectance. By using that reflectance, we can be able to judge that this may be this object. Okay. So here you can see on x-axis and y-axis. On the y-axis, you have got the reflectance in percentage and then wavelength in micrometers. So what you can observe here, only few things we have shown. The dark blue color, it is the clear water. Then after that, turbid river water. The vegetation is shown. Dry soil, wet soil is shown. So what is the x-axis and y-axis? Y-axis is reflectance percentage and wavelength. So as the wavelength increases, so how the dry soil is behaving, how the wet soil is, both are soils, but depending on the wavelength, it is the reflectance varies. Water is there, but the clear water, it will have the reflectance like this. If you have turbid water, the wavelength differs. Okay, so depending on this, What is this 0.4 to 0.7? What is the significance of this? This is the visible region. So blue, green, red, then near infrared, mid infrared. So here, suppose this particular point is there. I have seen, so I can get the vegetation. This reflectance, it is increasing. Okay, but here, what is the inference of this? Clear lake water and turbid river water. So what is your inference on this by seeing that? But see the graph and tell what is the inference? What is the conclusion?
Clear water can observe much than turbid river water.
Clear lake water has less reflectance, okay, than turbid river water. So more absorption. Is it that? Okay. So that is okay. So but this is just a representation. So this spectral signature is used for identifying the object. I think in the yesterday discussion, I have seen the satellite images, how it will be. So nothing is mentioned, some picture will be there. So you are going to identify the objects. You are going to identify depending on these things. Okay, next. Now we can see this spectral response of Earth surface features. All are taken from same satellite, same sensor. We have got different aspects here. You can see true color, false color, then different bands. Blue band, green band, red band, then near infrared band. How I can identify that this is a blue band? 0.4 to 0.5. 0.5 to 0.6 is green. 0.6 to 0.7 is red. Then 0.7 to 0.9 is near infrared. So why you have taken this? So within that satellite, you have got the sensors, means you can identify that these are just like cameras. You can get so many pictures. One is black and white, you can get that, you are going to call it as a pan. Then you can take individual bands. So why you are going to take these bands? You can able to identify the objects in some specific bands. So that is true color composite is the actual picture. If you reverse the colors, then here you can see what the vegetation is shown in the red color. You can identify the vegetation. In the blue color, the sand will be identified. That comes by experience. Then red color 2, that is vegetation can be identified. And in the 3, water can be identified clearly. Okay. So what is the principal insight? Incident electromagnetic energy interacts with the target and the resultant scattered wave contains the fingerprint of the target. In terms of its unique signature, reflected or emitted electromagnetic energy from Earth's surface is observed in different wavelengths of the spectrum to understand the target signature. So, electromagnetic energy from the sun, it is going to hit the various objects and then it is going to interact with the target, and after that what happens is, again it is reflected, no, then it will take the fingerprint of the target in terms of its unique signature. It will have its own characteristics. By using those things, we can able to identify that this is water body, this is a forest, and within the forest also there may be coniferous forest, deciduous forest. The land is there, barren land, it may be grassland, okay, depending on the categorization. So next, yes, electromagnetic radiation interaction with the atmosphere. So electromagnetic radiation is passing, it passes through the atmosphere, it's the Earth surface. How it is going to interact with the Earth surface already seen. What are the 3 things that will occur? Interaction with the Earth surface. Reflectance, absorption, transmission. Now it is passing through the atmosphere. No? The electromagnetic radiation from the sun, it passes through the atmosphere, hits the Earth surface, again passes through the atmosphere. So 2 times it will pass through the atmosphere. So 3 fundamental interactions occur when electromagnetic radiation is passing through the atmosphere. What are the three? Scattering, then absorption and transmission. Transmission and absorption both are common. Earlier we have shown that it is reflection, now it is scattering. What is the difference between this reflection and scattering? Okay, right, yes. I will let you know. So, next. Electromagnetic radiation is attenuated by its passes through the atmosphere. Attenuation, so it will get reduced, is it not? Because from the sun it is passing, there will be loss. Again hitting the land, there will be loss of energy. Again it passes through the atmosphere, there will be loss. Loss in the sense, some energy will be absorbed. And finally it is going to reach the sensor. So there will be some reduction. What may be the reduction? That is by scattering and absorption. These are the two reductions. Transmission, it is always there. Okay. So scattering is the redirection of radiation by reflection and reflection. Attenuation is wavelength dependent. Okay, next. So in the atmosphere, you can see the picture. In the atmosphere, what are the things that we can get in that? So altitude, first 2 to 3 kilometers, water and aerosols will be present mostly. And above that, up to 8 gas molecules. Then the influence of the oxygen, carbon dioxide and trace gases. And over and above 20 kilometers, up to that atmosphere, ozone. That ozone will be in a significant quantity. And all of you know from childhood we are studying. So because of the greenhouse gases, ozone, there is some depletion of ozone layer, and if some aperture forms, what happens? If some hole happens, what happens? The whatever may be the ultraviolet radiation is directly going to kill. That everybody knows. So greenhouse effect, why it is becoming warm? Because the radiation is coming, but again it is being trapped because of these things. Okay, so we have got gases, we have got the gas molecules, water molecules, and then ozone. These are all present. Why you are going to study this? Because these gases, ozone, oxygen, carbon dioxide, they are going to absorb some of the energy. They are going to absorb some of the energy. That we are going to discuss next. Yes, there are 3 types of scattering. First, what is scattering? Reflection means, you know, it is in a specific direction. Scattering means the reflection in any direction. Okay, so direction is predictable in reflection. So if you hit a ball like this, it will again come in the same direction, but random. Scattering means it is random. Direction is unpredictable, so it is called as scattering. Now, based on the wavelength of incident radiant energy, the size of the gas molecules, dust particles, water vapor droplet, 3 types of scattering are possible. What are these? 3. One is Rayleigh scattering, another one is Mie scattering, third one is non-selective scattering. So how you have categorized this? Depending on the size, dust particles, wavelength, all those things will come into picture. So the first one is Rayleigh scattering. It is due to gas molecules. The size also includes gas molecules. Mie scattering, it is due to smoke and dust. Non-selective scattering is due to water vapor. It is due to water vapor. Because of these things, we have got some of the things that are going to happen in our nature. Next. Yes, all of you please observe. This is Rayleigh scattering. See the graph. Earlier you have seen percentage of reflectance and wavelength. What is this? Intensity of scattered light versus wavelength. And what I have shown, I have not shown the entire spectrum because you are seeing what is our capacity. Visual light only we can able to see 0.4 to 0.7 micron. Is it not? Remaining whatever the electromagnetic spectrum is there, that we cannot be able to see. Okay, so 0.4 to 0.7. So in that 0.4 to 0.5 is your blue, after that green, and after that red. So blue will be first, green, red. So here intensity of scattered light. Here you can see intensity of scattered light is more in the blue, whereas it exponentially decays to very less in terms of red. So it is blue is exponentially high when compared to the red. So scattered by the molecules and particles whose diameter are very very less, whose मुझे नहीं चाहिए, वो प्रोफेसर को चाहिए 10 मिनट. So scattered by molecules and particles whose diameter are very less, primarily due to oxygen and nitrogen molecules. And scattering intensity is proportional to the lambda to the power of -4, means inversely proportional. Scattering is inversely proportional to the wavelength to the power of 4. And the blue sky is due to this. Why blue sky? Because the blue color is more scattered. Blue color is more scattered. Yes, next. So here, suppose blue radiation is there, the wavelength is 0.4. What is the range of blue? 0.4 to 0.5. Then green is 0.5 to 0.6, and then 0.6 to 0.7. Is it not? So blue radiation, you have, suppose you take 0.46, and red is 0.66. So what is the relation? It is scattering is directly proportional to the lambda power of -4. So 1 by lambda to the power of 4, inversely proportional. So if you can calculate, it is 4 times. So what is the essence? Blue color is 4 times. It has got more scattering than red radiation. Any child is there who is very hyperactive. You see anywhere he will be available, like that blue color. Because scattering you cannot predict. Okay, so scattering blue color, why? Here the sky is blue because scattering. Okay, because red color is going to exhaust. Blue color is available. Yes, next. My scattering, the spherical particles that have mean diameter between 0.1 to 10, water vapor, smoke, fine dust. Scattering is proportional to lambda to the power of 4 to lambda 0. So it is reducing. Earlier it is directly lambda to the power of -4. Here it is lambda to the power of -4 to lambda, means wavelength is decreasing. So clear atmosphere has got both Rayleigh's and Mike. The combined effect is like this. Next book. Yes, this is the effect of red sky at the evening. At the sunset, what happens? Already you know, blue, green, red. At the sunset, you see that whenever there is a noon, what we will feel? More heat. Why? Because the sun is on the top and it will be generating. Whereas during the sunrise and sunset, it will be far distance. So whenever distance is more, what happens? Blue wavelength is less when compared to the red and orange. V.G.K, violet, indigo, blue, green, V.G.K, yellow, orange and red. So because of the distance, what happens is all these things are exhausted. Orange and red will be remaining because it will travel more distance. So that's why during sunset and sunrise, you can see the orange color and then light red. And during midday, what happens? During midday, you will have, you cannot able to see with the naked eye. Yes, next. Yes, the third one, non-selective scattering. Non-selective scattering. Aerosol particles, where you can get this aerosol, go to the previous slides. Whether aerosols are there at the top or at the bottom. Water and aerosols. Next, go to the previous slides. Next, previous slide. Yes, previous slide, that graph. Yes, previous slide. Yes. Water and aerosols are at the bottom. That is 2 to 3 kilometers. Water and the aerosols. So, yes, next go to that slide. They are available there. They are having more wavelength Water droplet, ice crystals, volcanic gas, smog, these are all present above the sky which is near to the earth. So this non-selective scattering is independent of wavelength. So it is not at all depends on the wavelength, whether it is a blue, green, red, whatever may be the color. All the colors are there. It is independent. When all the colors are there, which is scattering equally, then what is the final thing? It is white. That's why the clouds are white. Because it is irrespective of the wavelength. Normally earlier too depends on the wavelength. Blue is there, green, indigo, orange, yellow, red. Why we are bifurcating depending on the wavelength. But this particular scattering, that is non-selective scattering, it is independent of wavelength. If it is independent of wavelength, what are the colors we have? Red, blue, green, major colors. All are scattered equally. If all are scattered equally, white will be there. So that's why clouds are white in color. So you have got three answers, is it not? So that is the reason why the clouds are white in color. Yes. So we'll come to the end. Atmospheric absorption. I already told these are all the gases which they are going to absorb the radiation. So there will be decrease of the electromagnetic radiation. Yes, next. So the atmosphere prevents or strongly attenuates transmission of radiation through the atmosphere. So the atmosphere prevents or strongly attenuates. Attenuates means it will decrease the radiation. So ozone, carbon dioxide, water vapor, they are all going to absorb ultraviolet radiation, mid-end for infrared and mid-end for infrared region in these levels. So ozone, we have studied from basic classes, it is going to absorb the ultraviolet radiation. Because of this pollution, all those things, if the aperture forms or that ozone layer decreases, what happens? Ultraviolet radiation will directly pass and then it is going to hit the people which will have. Yes, next. Yes, this is the last thing. Atmospheric windows. Atmospheric windows. What is this atmospheric windows? Whenever we are passing any journey, so where you will sit? So nearby the window. Here, in this particular hall, if I want to see any outside person, here I can able to see, no, but that is the way. So the thing is, how we can be able to get the information of the objects, where I can get the information. So the atmosphere is practically transparent in visible electromagnetic region, whereas opaque in other regions. Remote sensing utilizes the transparent regions known as windows to affect the effect of the absorption of radiation. So you can see another graph, wavelength as well as atmospheric transmission. So already some of the energy is being absorbed by the gases and then it is absorbed by the earthen features. But then also you cannot be able to visualize that particular radiation because the atmosphere is opaque. Opaque means you cannot be able to see. But it is open in some of the regions. That regions we are going to utilize. So you can see that graph, atmospheric transmission. What is the visible region? What is the visible region? 0.4 to 0.7. Luckily 0.4 to 0.7. We have nearly more 100%, near to 100% atmospheric transmission. That's why you can able to see the sun. That's why you can able to see the stars. Is it that? If it is opaque, what happens? Nothing you can able to see. Are you getting me?
Yes.
So the atmosphere is open or it is clear in visible region. So that's why you can able to see the all the features. Then if you see here, what is happening here? The wavelength is increasing in this particular region. All the energy, whatever is there, is being absorbed by the water molecules in this region. Whereas here, it is absorbed by carbon dioxide. Already I told carbon dioxide, oxygen, ozone, they are going to absorb the energies. So here, can I utilize the remote sensing data? No, because it is opaque. Where I can utilize here, visible region, then infrared, in the thermal infrared here you can see, this is thermal infrared. Okay, some of the portions you can utilize, and also microwave. Microwave, this is the reflectance. But here, entire portion, carbon dioxide. Here also you can see oxygen. Oxygen is going to absorb. Okay, so what are the windows? 0.38 to 0.78 microns. There you can able to get information wavelength. Then 0.72 to 3 microns. Middle line near infrared, and then thermal infrared 8 to 14. Here you can extract the information. So by visible light, that is from 0.4 to 0.7, we can able to get the information, and also this infrared region we can utilize. We can get some information of the objects. Finally, what is the thing? You want to get some information of Raipur by sitting here. Okay, you can order the satellite image. We can able to see, and whatever the projects you want to do, you can identify the objects. How we can able to identify the objects? By using these maps, what we are going to get. Okay, then in the further classes we will see some of the other concepts. What is this false color composite? Okay,